This video, we're going to look at solving nonlinear inequalities in one variable. So quadratic inequality is the concept here. So if we had a trinomial like x squared plus 3x plus 10, something like that, and we wanted to know which x values would make this true, where we plug in some x values to make this less than or equal to 0. What would be the answer there? That's what we're trying to solve. I don't even know if I just kind of created a trinomial off the top of my head. I'm not even going to do that one, but I'm just showing you that's what it's going to look like. A quadratic inequality where it's quadratic with an inequality there. So less than or equal to 0 or greater than or equal to 0 or some other value. So let's take a look at number 1. So if x minus 3 times x plus 4 is greater than 0. So we want to see our region. So I want to take each value and set it equal to 0. So I'm going to set x minus 3 equal to 0, x plus 4 equal to 0. So we're solving that equation. That's going to be adding 3 to both sides. So x equal to 3. I'm going to subtract 4 from both sides. Oops, didn't mean to do that. So, minus 4. So x equals negative 4. So that creates a couple zones. I'm going to throw these onto a number line. So we have negative 4 and we have 3. What I want to know is for which region is going to make this statement true, because I want to know all the x values that are going to make this true. So like I could take x equal to, I don't know, let's say 5, and that would be 5 minus 3, which is 2, 5 plus 4, which is 9, 9 times 2 is 18, 18 is greater than 0. So the number 5 works, but I want to know what are all the possible x values. So this, setting this equal to 0 creates 3 boundaries. So I want to take a value in this boundary, I want to take a value in this, and this. So I want to take a value in each of these 3 regions here and test them out with our inequality and see if we get a true or false statement. So I'm going to take a number from this first region. So this first region is from negative infinity up to negative 4. So I want to take a number in that region not being negative 4. So let's just do negative 5. Since negative 5 is going to be my test point. In this region, negative 4 to 3, 0. If 0 is in your region, use 0. That's the easiest one in most cases. And then 3 out to infinity, so let's just use 4. So I'm going to take each of these test points, plug them into the inequality, and see if we get a true or false statement. If we get a true statement, that means that that region works. If we get a false statement, that means it doesn't. So negative 5 minus 3, so this first region, negative 5 minus 3 times negative 5 plus 4 is greater than 0. So let's see. Negative 5, and all we're really worried about, to be completely honest, is we're really just worried about, in this case, is it greater than 0 or less than 0? We're trying to see true or false. So I don't really care what the actual number value is. I'm really just worried about the sign, if it's negative or positive. But if you want to just stick to just solving it, so negative 5 minus 3 is negative 8. Negative 5 plus 4 is negative 1, greater than 0. Negative 8 times negative 1 is positive 8. Positive 8 is greater than 0. Yes, that's a true statement. So that means that this, in this region, that works. So the numbers in this first region work. Let's check 0. For that region from negative 4 to 3. So this is going to be 0 minus 3 times 0 plus 4 greater than 0. 0 minus 3 is negative 3. 0 plus 4 is 4. Negative times a positive is going to be a negative. So negative 12. But it's just a negative, which negative is not greater than 0. So that one fails. So that region is not a solution. And let's try our last region, 3 out to infinity. So my test point is going to be 4. 4 minus 3 times 4 plus 4 greater than 0. You can already see 4 minus 3 is positive 1. They're both positive, so positive times a positive is a positive. So I know that's going to work. 8 times 1 is 8, greater than 0. Yes. So this is going to be a region that works. So that means my solutions are going to come in the region negative infinity up to negative 4. And that's going to be a parentheses because we have strictly greater than. Then we have this gap between negative 4 to 3, so we don't want to include any numbers in that region. So then union that with 3 out to infinity. Don't confuse this with your test points. You see how like we have these test points here. don't use your test points as your region. That's just what we use to test, so make sure you're careful there. So negative infinity up to negative 4, unioned with 3 out to infinity. All right, so number 2, x squared minus 6x less than or equal to 0. So on this one, we want to factor. So factor out an x. So x minus 6 less than or equal to 0. Set both factors equal to 0. So I'm going to set x equal to 0. X minus 6 equal to 0. So that's just x equal to 0, and then I add 6 over to both sides, so x equal to 6. So our number line here, our regions are going to be 0, 6. So negative infinity up to 0, 0 to 6, 6 out to infinity. Unfortunately, we can't use 0, so that's not going to really help us out. So negative infinity up to 0, let's use negative 1. 0 to 6, let's use positive 1. 6 out to infinity, let's just use 7. We're really just worried about the sign. Is it positive or negative because it says less than or equal to 0. So let's do the first one, negative 1. I'm going to use my factored form. I'm not going to use the original inequality because then I'd have to do negative 1 squared and everything. So it's just easier if we just do it like this. So negative 1 times negative 1 minus 6. That's going to be negative 1 times negative 7. Negative times a negative is a positive 7. Positive 7 less than or equal to 0. No, it is not. So that's a false statement. So numbers in that region don't work. Let's try out the next region. My test point in the next region is 1. So 1 times 1 minus 6 less than or equal to 0. 1 times 1 minus 6 is negative 5 less than or equal to 0. 1 times negative 5 is negative 5 less than or equal to 0. Yes. Negative 5 is less than or equal to 0, so that's a true statement. So numbers in that region will work. And last region, 7. So 7 times 7 minus 6 is less than or equal to 0. 7 times 1, 7 minus 6 is 1, less than or equal to 0. 7 times 1 is 7, less than or equal to 0. That is false. 7 is a positive number. We want our numbers to be negative. So the only region that works is between 0 to 6. So to write that as an interval, I'm going to do brackets, 0 to 6, bracket. And the reason I'm using brackets is because it is less than or equal to. So we want to include the endpoints of 0 and 6. Next one, number 3. So same strategy. Now we just have a lot of regions that are going to be created because I have these 3 factors. Should be a parentheses right here. So I have these 3 factors. So x minus 3 equal to 0, x plus 1 equal to 0, and x plus 6 equal to 0. So that means x is equal to 3, x is equal to negative 1, and x is equal to negative 6. So we have a lot of regions that are going to be generated here. So I'm going to make my number line pretty big. So my first one is negative 6. Next one is negative 1. And then we have 3. So we have 3 potential regions of negative infinity up to negative 6. Negative 6 to negative 1. Negative 1 to 3. 3 to infinity. So we have 4 regions that we have to test. So let's write down our test points. I'm going to use negative 7. I'm going to use negative 2 in this one, negative 6 to negative 1. I can use negative 2. Negative 1 to 3, 0. That's going to be good. And 3 out to infinity, use 4. So a little bit of some messy work here. So for this first interval, I'm going to try to keep this as clean as possible. I'm going to do this over here, actually. So for my test point of negative 7, so I'm testing out negative 7 here. So this is going to be negative 7 minus 3. Negative 7 plus 1, and then negative 7 plus 6, less than or equal to 0. And I would try to shortcut this. I mean, you could use your calculator, it's not a big deal, but I would try to just shortcut this and just look at the sign. So negative 7 minus 3 is going to be a negative 10. Negative 7 plus 1 is going to be a negative 6. So negative and a negative. And then negative 7 plus 6 is going to also be a negative. So we have 3 negatives being multiplied together. When we have 3 negatives being multiplied together, then we get a negative. Negative times a negative is a positive. Positive times a negative is a negative. So that first region is going to be a negative, less than or equal to 0. Yes, I don't really care what the actual number is. I just want to know if it's positive or negative. So that one came out to be true. And if you're not catching that line of thought, like why are you just looking at the signs? Just multiply it all out. Just do negative 10 times negative, 6, and then times negative 1. Just multiply it all out if you want to feel safe. But I'm just trying to make this a little less impactful, a little less strenuous. So the next region, negative 2. So we're going to do negative 2. So I'm testing out negative 2 here. Negative 2 minus 3, negative 2 plus 1, and negative 2 plus 6. Less than or equal to 0. So the negative 2 minus 3 is negative, because that's negative 5. Negative 2 plus 1, another negative. Negative 2 plus 6 is a positive. So what do we get here? Negative times a negative is a positive. Positive times a positive is a positive. Positive is less than or equal to 0. No, it is not. Oops, I forgot to highlight my first one. First one worked, so that one worked here. So the next one does not work, so no to that one. I know my camera's like right in that corner there, so I'm going to try to maneuver around that. I'm going to go up here. So now I'm going to test out 0. So testing out 0, this is going to be 0 minus 3, 0 plus 1, and 0 plus 6. Less than or equal to 0. 0 minus 3 is a negative, not negative 1, but negative. 0 plus 1 is a positive. 0 plus 6 is a positive. Less than or equal to 0. Negative times a positive is a negative. Another negative times a positive is another negative. So we get a negative less than or equal to 0. Yes, that one's true. So this region worked. And last region, testing out the number 4. So this would be 4 minus 3, 4 plus 1, and 4 plus 6. 4 minus 3, positive. 4 plus 1, positive. 4 plus 6, positive. Positives all around. So that's going to be a positive. So positive greater than or equal to, or less than or equal to 0. Positive less than or equal to 0. Nope. That is false. So no solution there in that last region. So no to that one. I'm trying to shortcut this a little bit. So if you don't like using just the signs of understanding if it's positive or negative, then multiply it all out. Not trying to steer anyone away from doing that. Just, we don't really care what the number is. We just want to know if it's positive or negative because we're comparing it to 0. So my regions then is from negative infinity up to negative 6, and we're going to use a bracket because we have less than or equal to. And then I have a gap. So then I got to union that with brackets negative 1 to 3 with another bracket. And then that's it. I don't have like a out to infinity or anything like that. It's kind of a weird interval, but that's our solution. Rational inequalities. Rational inequalities, kind of a weird thought process here. To solve this, we first want to identify which values will make the denominator 0. So in our example here, x plus 5, I want to set the denominator equal to 0 because I want to know what's going to make this 0. So that's going to be minus 5, so x equals negative 5. So there we go. There's our first kind of point that we want to keep in mind. X equals negative 5. And then from here, we want to solve the equation that's generated. So this is going to be x minus 4 over x plus 5 equal to 0. So we're just setting up the equation of equal to 0. And then we solve this, And this is actually a much easier solve than it looks, because when I cross multiply, like this is technically a 0 over 1. So if I cross multiply, because I just have a fraction equal to a fraction, x plus 5 times 0, x plus 5 times 0 is 0. So it's x minus 4 equal to 0. Because x minus 4 times 1 is x minus 4. X plus 5 times 0 is 0. So x minus 4 equal to 0. And then I add 4. So I get x equal to 4. So on the number line, same strategy as what we were just doing a second ago. On the number line, I have the number -5. I have the number 4. We want to use test points again. So the first region, I'm going to test out -6. Second region, from -5 to 4, 0 is in that interval, so use 0. And then +4 out to infinity, let's just use 5. So here we go. First one, -6 minus 4 over -6 plus 5 less than or equal to 0. And I would kind of encourage just looking at the signs. So -6 minus 4 is -10 over -6 plus 5 is -1. So negative over negative is a +10. +10 less than or equal to 0. Nope. So that region does not work. Next one, 0. So 0 minus 4 over 0 plus 5 less than or equal to 0. So 0 minus 4 is a -4. 0 plus 5 is a +5, less than or equal to 0. Yes, that is negative. Negative is less than or equal to 0. So that is that's going to work. So any number in that region will work. And last one, testing out the point 5. So 5 minus 4 over 5 plus 5, less than or equal to 0. 5 minus 4 is 1. 5 plus 5 is 10. Positive, less than or equal to 0. Nope, that's false. So that region is not going to work. So our interval solution, I'm going to write it right here, is from -5 to 4. All right, number 5. Same concept. We want to know what is going to happen with the denominator, so I want to set the x plus 1 equal to 0. So I'm just trying to figure out what is going to make the denominator 0. So I subtract 1, x equals -1. So I have x equal to -1, and then solve the equation, just like we were talking about a second ago. So 3 over x plus 1 equals -2. Now this time, since it's not equal to 0, the big difference here is we're actually going to have to solve this. On this one, the reason that I just got x minus 4 equal to 0 was because I did 0 times x plus 5, which is 0. But here, it's 3 over x plus 1 equal to -2, so that I actually have to multiply. And this is over 1. So this is 3 times 1, which is 3, equals -2 times x plus 1. So that I actually have to multiply out and solve this. So I'm going to distribute the -2. So 3 equals -2 times x is -2x. -2 times 1 is -2. Add 2 over to both sides. 3 plus 2 is 5 equals -2x. Divide by -2, so we get x is equal to -5 over 2. So my numbers I have to look at is -1 and -5 over 2. Be careful here. It's kind of easy to make a mistake here. When throwing these onto a number line, -5 over 2 is going to come first. That's smaller than -1. I would approximate this decimal, or this fraction, into a decimal. so you know exactly which points you could use, because it's kind of hard looking at a fraction and knowing, like, could I use -2, -3, which one for that region. So this is -2.5, so this is from -infinity up to -2.5, so just use -3. Then I have from -2.5 to -1, so that I have to use -2. And then -1 out to infinity, so we could use 0. I'm going to do my tests over here, some kind of room. I don't want to go too far down because I want to keep this in frame. So I'm going to test out -3. So let's test out -3. So -3 test is 3 over -3 plus 1 less than -2. So 3 over -3 plus 1 is -2 less than -2. So if you're looking at the fraction of 3 divided by -2 and you're like, I'm not really sure if that's less than -2, just type it in your calculator. 3 over -2 is -1.5 less than -2. That is false. -1.5 is greater than -2 because -1.5 is closer to 0. So that's actually a false statement. So no, it does not work. So no. Let's test out -2. So this is 3 over -2 plus 1 less than -2. So 3 over -2 plus 1 is -1 less than -2. 3 over -1 is -3 less than -2. Yes, -3 is smaller than -2. So that is going to be a true statement. And 0. 3 over 0 plus 1 less than -2. 0 plus 1 is 1 less than -2. 3 less than -2. Nope, false statement. So our solution is from -5 over 2 to -1, just in that middle region there, because this did not work and that endpoint did not work. So this section, I don't think it is strenuous. I think it's kind of repetitive and a lot of just working with fractions and just adding, subtracting numbers, multiplying numbers. But the level of difficulty, we can multiply positive, negative numbers. We can add and subtract numbers. We can deal with fractions. We can deal with all those kind of skills. It's just being very, very careful with your signs and everything, which could cause some issues. So that's where you really want to focus your energy on. But not too bad, though, in terms of what we're actually calculating and everything.